This is problem number 9 for section 2.3. In this problem it says, before contracting to grind engine cylinders to a cross-sectional area of 15 inches squared, you need to know how much deviation from the ideal cylinder diameter of C equals 4.37 and you can allow and still have the area come within 0.01 inches squared of the required 15 inches squared. To find out, you let A equal this formula and look for the interval in which you must hold x to make absolute value A minus 15 less than or equal to 0.01. What interval do you find? All right, real quick, let's break this down. C is 4.37. We know that L is 15 inches squared because that's what is required. So that's the limit that we need. We need that limit there. We know that epsilon has to be, well, epsilon is going to equal 0.01 inches squared, meaning that we have to be within 0.01 inches squared for this to, within 0.01 inches squared of 15 inches squared for this product to be a good product. They want us to look for the interval in which you must hold x to make this true. Well, they're really telling us, if we go back to our problems here that we've been doing, they're saying, all right, we have some equation. I'm just going to draw one. We'll just draw a linear one because it's easy. We have some C value that's 4.37. We have x values that we don't know that we're going to try to find that produce y values. And the y value we need, or the limiting value, is 15 inches squared, right? We need that area. And this is our tolerance here, 0.01 inches squared. And our tolerance here is 0.01 inches squared. So they're asking us to find these, basically the tolerance for our cut here, our diameter, right? The tolerance for our diameter that will keep us within an area of 0.01 inches squared of 15 inches squared, which is the area we need. Now, that's the conceptual piece. The actual part of the problem is you take the A. Now, notice that this is already set up. This is the absolute value of f of x minus L less than epsilon. This part right here is written there. That's what that is. All we have to do is take our equation and plug it in for A there. So we can say absolute value of pi x over 2 squared minus 15 is less than or equal to 0.01. And then we just need to solve. So I always like to say this is absolute value of pi x over 2 squared minus 15 equals 0.01. And then we say, okay, this could equal 0.01, so pi x over 2 squared minus 15 can equal 0.01, or pi x over 2 squared minus 15 could equal negative 0.01. Now we start to solve. So this is going to be pi x over 2 squared equals 15.01 when you add it over. Now divide by pi. So we're going to divide by pi on each side. And I'm not going to write it out. I'm just going to write out the steps without writing out the division. So I have 15.01 over pi. I'm going to square root each side. Now, when you square root each side, we can essentially ignore the negative values because we know that in this case we're talking about diameters. Diameters can't be negative. So we're just going to ignore the plus minus part of this. So this will be x over 2 equals root 15.01 over pi. And the last step we're going to do is we're going to say x equals, we're going to multiply 2 root 15.01 over pi. We'll do the same thing on this side. This will be pi x over 2 squared equals, this will be 14.99. We're going to divide by pi, so we're going to get x over 2 squared equals 14.99 divided by pi. Square root each side, so x over 2 equals the root of 14.99 over pi. So x equals 2 root 14.99 over pi. So we're going to go ahead and put those in. 15.01 divided by pi. Then we're going to take the root of that number and take it times 2. And we get 4.37, oh, what do they want us to round to? Maybe 7, we'll go 7.7. And then we're going to do the same thing on the right side. So we're going to take 14.99 divided by pi, take the root of it, take it times 2. And this time we get 4.369. All right. Let's make sure we got that. 3.7. You know, I wrote this wrong. This is actually 3.717. I screwed that up. So this is actually a 1 here. Okay, so this part is 4.369. This part is 4.371. Now, if we take 4.37 and we plug it into the inequality, when we plug it in, 4.3, so this is like where we draw the number line, right, with the method that I use. We draw a number line, and we put 4.369 on this side. We put in the middle 4.37 here, and we put out here 4.371. And we check to see, are the solutions between the 2 points? Well, we know that's going to be the case, but we can double check it. 4.337 divided by 2, square it, times pi, minus 15, and that gives you a number that is less than or equal to this number here. So yes, the solutions run from here to here. So our interval then, they said look for the interval, is 4.369 to 4.371 for the solutions. And actually the endpoints work for this because they keep us right at the tolerance. And the reason the endpoints work is because of the sign less than or equal to.